Hi everyone, welcome back. This is our 18th class and this class is all about HPS system. This class is going to be very interesting and informative. I hope you will enjoy this session. So without delay, let's get started. Learning objective: foundation of HPS system, hydraulic circuit, auto filter unit, engine driven HPS pump, electrical driven pump, and last safety block. So all this topic we are going to cover in this chapter. In this session we will learn about the following items. This is the block diagram of ME engine hydraulic system. Here various topics are given. Whichsoever will be in green color, we will talk about that topic. So first one is system. HPS means hydraulic power supply. This is a system in which main engine lube oil is processed and used as a hydraulic oil, which in turn after pressurization used for operating fuel oil booster, exhaust valve actuator and cylinder lubricator. There are three main type of HPS system installed on a ME engine. First one is engine driven pump with electrical pump, in which electrical pump is just for a startup. The engine cannot run if all engine driven pumps are kaput. Second one, engine driven pumps with electrical pump, in which electrical pump is capable to run the engine up to 15% of full load. The engine can run at maximum 50% load if all engine driven pumps are kaput. And last, third one, no engine driven pump installed and only 4-5 number of electrical pump will be there, out of which 1 or 2 pump will be running at 75% capacity all the time and rest will be started sequentially as per consumption demand. So these three types of configuration you will find in the HPS system. On the basis of pressure, there are two type of hydraulic system. First one is 200 bar system and second one is 300 bar system. 200 bar working range is 120 to 210 bar and 300 bar working range is 220 to 250 bar. Now let's see with the help of example. So here you can see this set point is at 196 bar. This comes under this range, that's why this is 200 bar system. Next example, here set point is 225 bar. This comes under this range, that's why this is a 300 bar system. Now moving next, on the basis of configuration there are two types. First one is hydraulic system is extracted from main engine lube oil system, and second configuration is hydraulic system lube and main engine lube oil system lube are separate. But in both case, main engine lube oil is used as a hydraulic oil. So please do not get confused that hydraulic oil is something different. Hydraulic oil is same as that of the main engine system lube oil. Now this picture is depicting that main engine lube oil and hydraulic oil loop is same. This is main sump. The oil is coming to these pumps. After that it is going to cooler, and from the cooler it is going to the full flow filter. And this is the place where the bifurcation of hydraulic oil is taken. That means the branch is taken from this point. So here written a starting of hydraulic system. This is represented with the RU. Now let's have a look in the next picture. This is the point RU. This is the bifurcation from the main engine lube oil system going to this changeover valve. This is manual filter and this is automatic filter, and after that it is going to the various HPS pumps. So this one is representing the common loop for main engine lube oil system as well as hydraulic system. Now contamination of hydraulic oil must not exceed, as per the ISO 4406, 16 and 13, in 100 ml oil sample the number of particles with the size should be within the range That means as per 4406-16, the number of 6 micron particle should be between the 32,000 and 64,000, and as per the 4406-13, number of 14 micron particle should be between 4,000 to 8,000. So this is the standard requirement as per the ISO for this hydraulic oil. So this criteria will be met by this automatic filter. Now this figure representing the main engine lube oil and hydraulic oil has separate loop. So according to this figure, there are basically two loop. So first loop is main engine lube oil system and second loop is hydraulic system. In hydraulic system, it also contains filter, cooler and pump, and drain to sump from the engine is common for both loop. So these are basically two type of configuration based on the loop. Now I am going to discuss about the electrical and engine driven pump configuration. So this is the configuration number 1. In this picture you can see this is the electrical driven pump and these three are engine driven pumps. So configuration number 1 is all about the electrical plus engine driven. Configuration number 2 is all about the only electrical driven pumps. You can see there is no engine driven pump installed in this engine. So basically you will find these two type of configuration based on the electrical or engine driven pump. This is the detail about the configuration number 1. These two are a starter pump called electrical driven pump and these three are engine driven pump. This is common manifold which is connected from the main engine lube oil system, or if loop is separated then it is coming from the fine filter. Hydraulic oil pressure is increased with help of these three pumps and it is sent with help of this type of flexible hose, and finally it is going to the safety block unit. Now we will talk about the filter unit. This is the filter unit, so we are going to see about the same. This is called the manual filter and it is of 25 micron. This is auto filter and this is of 6 micron. This candle filter is of this auto filter. This auto filter must be in use all the time, and in case of any maintenance this manual filter can be used. This is the indicator of differential pressure across the filter unit. Now next, this is the internal configuration of the automatic filter. This picture is talking about the filtering process. Oil comes from here, it enters from this cylindrical area and comes out from this opening, and after coming out it goes to HPS pump. This picture is depicting about the back flushing process. In this process, the pressurized pneumatic air is used to back flush these candle filters. Air comes from here, this valve open, and then air goes all along here, and with help of this rotating distributor the inline filters will be connect to this air pressure, and then air will enter through this hole and comes out from this surface area and ultimately flush out the filtered particle. This is how the back flushing process occur. Back flushing initiated at interval of every 4 hours. Pressure dependent back flushing initiated at differential pressure equal to 0.6 bar. Pressure dependent alarm initiated at 0.8 bar. So this is showing that differential pressure is within limit, and this red indication is showing that differential pressure is approaching to alarm level. Our next topic is starter pumps. So these are starter pumps. So we'll talk about same. These two are electrical driven pump, that is called a starter pump. This is the main inlet line. These are two main shut-off valve. These two are pumps, and after pressurization the oil passes through these flexible holes and goes straightway to safety block. These two are relief valves, that's valve number is 312 and pressure set point is 175 and 225. 125 in case of 200 bar system and 225 bar in case of 300 bar system. Now question is, why two pumps is required? Why not one? Answer is just because of redundancy purpose and nothing else. If one pump kaput, there is no need to worry. Engine can be start without any issue. This is the MOPS screenshot of HPS system. Here written safety valve setting 175 and 225 bar, 175 for 200 bar system, 225 bar for 300 bar system. This is valve number 312, which is just a relief valve situated on this individual pumps. Now automatic mode stopped at finish with engine. These two pumps will automatically stop when you press finish with engine. Master pump running at engine standby. When you keep engine in standby, the master pump will start automatically. Both pumps are running during pressure buildup. When you press standby, this master pump start first, followed by slave pump. Both pump will keep on running till the time engine load raises to 15%. As the engine load reaches to 15%, both pump will stop automatically. In manual mode, controlled by operator via the main operating panel. That means if I change this HPS mode from auto to manual, then I can stop this pump from MOP itself. These are two electrical driven pump, basically motor, and these two are pumps. These two are relief valves, valve number 312. This is called the minimus coupling, which is a pressure checkpoint for these individual pumps. In case this pump is malfunctioning or generating less pressure, then you can just connect over here pressure gauge and check that whether there is a problem inside pump or not. If it is not building up sufficient pressure, that means either this relief valve has problem or the pump is kaput. So accordingly you can take action. This is the safety block about which I was stating before. This is the starter panel of electrical driven startup pump. You can start both pumps from here also. Or if you press this standby, both pump will start automatically. Another option, if you press here prepare a start, then also both HPS pump will start automatically. So our next fourth topic is engine driven pumps. Subtopic is pump design. So this is picture of engine driven pump, which is nothing but a Swash plate pump, and here these pump are represented like 1, 2, 3, 4 and 5. These pump are variable displacement type. That means the amount of flow from the pump can be altered and hence different pressure can be achieved. This is Swash plate angle indicator, and this is feedback unit. This feedback unit means this data 58%, 52% etc. is coming from this feedback unit. Now I am going to show you an engine driven Swash plate pump in which you will see some of its internal components. This is the engine driven Swash plate pump. Here in this area plunger and barrel are situated. This is a feedback unit for Swash plate position indication, and this is hydraulic control valve, also called main valve. This is the pilot valve and this is the driver unit. Now let's have a look from different angle. This is driver unit, this is pilot valve, and this is angle indicator. When pilot valve operates as per AC use 4 to 20 mA signal, then this hydraulic control valve received hydraulic pressure from here right side and from left side, and thereby causing this tapered part to move left and right. This feedback unit contains one spindle which has its bottom part in round shape, which facilitate it to have a up and down movement smoothly. The up and down movement of this spindle gives Swash plate pump load in percentage form like here. Next, here you can see this shaft is there which is rested on this tapered part, and when this tapered part moves left and right, accordingly this moves up and down. This is the picture of Swash plate pump. The first picture shows that Swash plate cam position is at 0 degree angle. So cam angle equal to 0 degree no pressure buildup in this situation. In the second picture, it is showing that cam is at its maximum position, and in this position maximum pressure buildup is possible. Here some parameters are given. In blue color, this is showing inlet pressure of 2 bar, red color outlet pressure 300 bar, this brown color is control pressure, and the green color is case drain. This is case drain. This all are control pressure, which basically drives this main hydraulic valve, which contains this taper part. This is inlet pressure and this is outlet pressure. Now going to show you animation part of swatch plate pump. So this is the swatch plate cam, and this is plunger, and these are barrels. When this cam is at 0 degree angle, then there is no pressure buildup, and when it moves to 15 degree angle, then hydraulic oil pressure buildup. So now you can see with help of animation. Here 0 degree angle, no suction, no discharge, and when it moves, then this a small area will become discharge and the large area will become suction, and obviously this whole system rotates. So this is how the swatch plate pump works. If you want to know detail about the swatch plate pump, you can always have a look on internet. In this picture you can see that this is the discharge line and this one is suction line. All pumps are connected with this engine. This square M means engine driven, and this circular M means electrical motor. That means when the direction of rotation changes from ahead to astern, this discharge port and suction port should be remain same, right? But question is, how does it happen? So have a look. This picture depicting the process by which, even though the direction of rotation changes, the suction and discharge port remains same in both ahead and astern direction. So you can see in this picture, when the engine is running in ahead direction, the swatch plate angle is like this. That means swatch plate is in ahead direction at maximum angle, and when the engine is running in astern, the swatch plate changes and that is in astern direction at maximum angle. So by this way swatch plate angle changes, and hence suction and discharge port remains same. Now next, this is one kind of configuration in which there are 3 pumps which are driven by the engine. First pump will be controlled by the SU1, second pump will be controlled by SU2, and this third pump will be controlled by SU3. Now let's see the other configuration. In this picture you can see there are 5 pumps driven by the engine. In this condition, first pump will be controlled by the SU1, second pump will be controlled by SU2, third pump will be controlled by SU3, this fourth pump will be controlled by ECU-A, and fifth pump will be controlled by the ECU-B. These 2 pumps are called binary type. That means either they will run in full ahead or in full astern, and these 3 pumps are of variable delivery type. That means the amount of flow can be altered, but here in this pump amount of flow cannot be altered. They will run at full load in ahead direction or in astern direction. Now going to discuss about peculiar property of swatch plate pump used in ME engine. If swatch plate pump control fails due to any reason, then swatch plate cam position moves to maximum ahead, and this movement is done automatically without having any interference from any external sources. So let's see. Here I am giving first example. This is SU1, 2, 3. This engine driven swatch plate pumps is controlled by channel number 70. So suppose channel number 70 or MPC itself get kaput, then this swatch plate cam will shift to maximum ahead position, like you can see over here. So this was first example. Now moving to second example. Suppose if this wire get cut or burned, then also this swatch plate cam will move to maximum ahead direction. So you can see. it has moved to maximum ahead direction. Now going to show you the third example. If driver or pilot valve fails, driver are installed over here, then also this switch plate cam will move to maximum ahead direction. So you have seen that there are three possibilities in which switch plate cam position moves to its maximum ahead direction. So this is a peculiar property of switch plate pumps which is used in ME engine. So now I am showing you one small video by which you can see practically that how does it happens. So let's have a look. Now I am going to pull out the channel number 20. See, it has moved to its maximum position in ahead direction. Now as soon as I will feedback, it comes to this 0 position. This is how the engine driven switch plate pump works. So conclusion is, in ahead direction, even all SU kaput engine will run because all will be shifted to its maximum ahead direction, so there is no any problem. But in case of astern direction, minimum 2 SU is required to run the ship in astern direction. Now suppose any one SU is kaput, then obviously corresponding to that pump will move in the ahead direction. So if engine is running in astern direction, then that pump will be of no use. Then only we will have left with two pumps which can deliver hydraulic pressure in astern direction. So this minimum requirement is for engine run at maximum RPM in astern direction. Even though these all three pumps get kaput, you can run the engine in astern direction up to load of 15%. Now next question is, why there are 3 engine driven pump, why not 2? Always remember, out of 3 pumps, 1 pump is always used as redundancy. That means only we require actually 2 pumps, not 3 pumps. Third one is just for redundancy. Now moving to next topic, that is switch plate pump internal component position at various condition like in a stop, ahead or astern. So case first is in completely dead condition. Suppose there is no pressure, engine is stopped and also electrical driven startup pump is not running. In that condition, what will happen? This pilot valve proportional valve will be positioned in such way that piston will be at its middle position, which will bring this cam position at the 0 angle degree. So in completely dead condition, the cam position will be like this. So there is no pressure built up in the hydraulic line. Now this is called the pilot valve and this is called the main valve. Pilot valve function is to change the direction of regulated pressure so that this main valve piston position can be changed, and this piston position is ultimately responsible for change of the flow and hence the pressure get changes. Now going to see case number 2. When channel 70 or driver power is on and engine in a stop condition, in that condition also switch plate cam will be at 0 position. There will be no pressure in this line, although the electrical driven pump is running because of non-internal valve is fitted in this discharge line. So there is no any pressure effect acts on this line, so it will remain at 0 position. Now going to see case number 3. In astern direction, engine in running condition. In that case, the hydraulic pressure will act here. The driver will change the pilot valve spool position in such a way that this pressure will act over here and it will move this piston in right direction, and hence this switch plate cam will change to astern direction. So this one is ahead direction and this one is astern direction. It will move towards the astern direction. So switch plate cam will shift to astern direction. Now going to see case number 4 and 5. Case number 4, maximum ahead condition. Case 5, if driver power fail, CPU fail or channel 20 fail. In all such type of condition, switch plate cam will move to ahead direction. In all such type of condition, that means driver fails, MPC fails or channel 70 fails, this spring force will come into action, and thereby this hydraulic pressure acts this side, which pushes this piston for maximum head position. Now going to talk about this regulated pressure. This is a flow control valve with fail-safe facility. The illustration of this valve is like this. Oil comes from here, it is restricted over here, and then finally goes to outlet. If this spring, this diaphragm or this spring damages, even though the flow will be continued, the flow will never ever restricted. That is why this is called self-regulating fail-safe valve. The main job is to control the flow. Now moving next, familiarization of hydraulic system window screen from MOP. Here I am going to explain one by one all boxes. First one is this box, HPS mode auto. From here you can convert the HPS mode from auto to manual. Normally it must be in auto. So when to use HPS mode in manual? First one, for purpose of function test of pump, pressure transmitter. These are pressure transmitter and various pumps are there. You can test all these pumps if you put HPS mode in manual. Second, in case there is an alarm for erratic hydraulic pressure due to leakages malfunction of NRV. If these NRVs are malfunctioning or because of leakages you are getting erratic hydraulic pressure, then you change it into manual and then accordingly you set here desired pressure. Next one is this change from auto to manual and vice versa you can do during running of engine without UC. Yes, this change of HPS mode from auto to manual you can perform even though the engine is running in any direction and at any load. Now how will you change HPS mode from auto to manual? For that, first of all you have to log in as a chief. After that you have to click over here. When you will click, then these two boxes will be opened. You have to click in this manual. After that you will have to click over this box, then various buttons will be appeared. As per your requirement you can change from these arrow buttons, and after that you have to click on this apply button. Then this desired pressure will be set. This is how you have to change HPS mode from auto to manual. Next going to see this pump torque limiter. You can see over here that this pump is running at 100% load and other pumps are running at 50% load. Sometimes it happens because of internal mechanical failure or leakages in pipe that one of the engine driven pumps run at its maximum load. However, it should not run at that much load. In that condition, the pump torque limiter alarm get activated. So when it will get activated, you have to click over here and then pump torque limiter you have to cancel. Although it is not advisable to cancel and run the engine without having any check, when you get this sort of alarm, if possible stop the engine and check particular pumps why it is running at higher load. Maybe some mechanical failure or some leakages is there. So when any particular pump reaches to its 100%, that time this swatch plate cam angle indicator will also show 15 degree. Now moving next, these two are starter pumps, electrical driven. This one is showing master and whichever is not showing master, that means it is slave. When these starter pumps start automatically, then these master pumps start first and slave pumps followed the master pump. You can select any pump as a master. When you select another pump as a master, automatically the previous pump will be changed to the slave. And this change can be done during running of the engine. So there is no problem. For changing, you have to click on this required pump and click over here, select as master. Now next we are going to see about this valve number 310. About these three valves 311, 312 we will talk in a while. This valve serve as a relief valve for this entire 5 number of engine driven pumps. Also in case of most of the shutdown, this valve depressurize this hydraulic oil pressure and hence engine stops. There are three ways to operate this valve. First one is if inlet pressure rises to set point. If the hydraulic pressure in this line rises to its set point, then it will lift this poppet and it will connect to the drain, and by doing so hydraulic pressure will become zero. Next, if valve is activated manually. This valve you can activate manually also. Here you can see there are two lines, that means there are two solenoid valves which are electrically driven. One solenoid valve is operated from the SU1 and another solenoid valve is operated through SU3. So you can operate manually from SU1 as well as from SU3. I will show with the help of video how will you do that. 3. If valve is activated automatically with shutdown activation, in which FIBA LFA operation is not required, and also by activation of emergency stop. So when you press emergency stop, then also these two solenoid valve get activated and hydraulic pressure becomes zero. Also in most of the shutdown condition, this both solenoid valve get activated and bring this hydraulic pressure to zero. Please note, not in all type of shutdown this valve get activated. Only in some specific shutdown these two valve get activated. Now I am going to take you to the MOPS screenshot of SU1 and SU3. This is the channel number 80 which operates one solenoid valve in the valve number 310. And from SU3, same channel number 80 operates the another solenoid valve of valve number 310. Now with help of this small video, I am going to explain you how will you activate manually this valve number 310. So just have a look. First of all, you need to change HPS mode from auto to manual. After that, you have to press this box, then click over here, SU1 open, and see this pressure will start reducing. Now see, pressure is reducing, and when I will click close, then pressure will start increasing. That means this valve is working from SU1. Now check same with SU3. Again pressure is falling. Now after clicking this close, pressure has started increasing. So this is how this valve number 310 is operated manually. This is a 6 monthly routine you have to carry out as per your plant maintenance schedule. Now going to talk about all these component which is encircled with this red line. That means all these three pressure transmitter, this valve 316, all these 9-turn valves, valve number 311 and valve number 310. That means I am talking about this safety block. In this safety block, all these components are installed. This valve is 311 and this one is 310. Pressure transmitters are installed over here. In ahead direction, this percentage will shown in positive, and in astern direction this percentage will shown in negative. Now next, as you know that this is the discharge line and this one is suction line, but why this line has been given? So we are going to talk about the same. What is the function of this recirculation line? As you also know that irrespective of direction of rotation of the engine, this swatch plate pump's suction and discharge port remains same, and that is maintained by this swatch plate cam orientation. In ahead direction, the orientation is like this, and in stern direction, orientation is like this, and hence the suction port and discharge port remains same. That means whether engine runs in ahead or in a stern direction, our direction of flow will be same. Here I have taken a case in which the engine is assumed to be running in a stern direction. Please ignore all this thing. Now what if the engine is running in stern and as of sudden swatch plate pump control fails? Obviously that particular swatch plate cam will move in ahead direction, and therefore the suction and discharge port will interchange, right? Now here you can see that no-intern valve is fitted, and as a result of it this pump will start running dry. So in order to safeguard the pump, this recirculation line has been given, which facilitate this pump to take suction from the inlet line and also discharge leads to inlet line itself. That makes the oil circulation in a closed loop, and by this the lubrication is provided to this pump. However, in this present case, this pump is not going to participate in building up the hydraulic pressure. So I hope you have understood that what is the function of this recirculation line. This is a very important line in this hydraulic circuit. Okay, now moving next, I am going to talk about this valve number 316. This valve number 316 must be always in closed condition except for testing and setting of relief valves. In a while I am going to explain the exact function of the valve number 316. Basically this is a very important valve in this hydraulic line. One more important point I want to share with you is that when emergency stop occurs, then these electrical startup pumps also get stopped, provided the control must be in remote, not in local. Okay, now moving next. Now going to talk about how to deal with hydraulic lines pressure transmitters failure issues. This is very important topic, and engineers must know about this one. This is the MOPS screenshot of hydraulic system. Here you will find some data are displayed. When you will click these detail buttons, then you will find some more data are displayed. You can distinguish between these two pictures, that here data are less and here data are more. Okay, now I am going to talk about this inlet oil pressure. This is actually an average of all LP pressure transmitters. That means this reading plus this reading plus this reading divided by 3. In the same way, this hydraulic oil pressure is also the average of all these 3 readings. This LP and HP plays a vital role as far as ECS algorithm is concerned in terms of failure of pressure transmitters. So now we are going to see the same thing in detail. Now here I am going to discuss about the HP and LP shutdown pressure data. For that I am representing one table. The first row represents 200 bar system and second row represents 300 bar system. This LP is representing this, which is the average of all these 3 reading. In the same way, this HP is representing this one, which is average of all these 3 reading. Now look at this LP. When low pressure reaches to 0.8 bar, then alarm will be displayed like this one, and when it reaches to 0.5 bar, then shutdown signal will be generated, and this is true for 300 bar system as well. In order to get this 0.8 bar and 0.5 bar, ECS algorithm is used. As far as the HP is concerned, there is no specific algorithm. So now we are moving to discuss about the algorithm part of the engine control system. So discussing algorithm, the algorithm is that if difference between any two input pressure reading, that means this pressure reading, is greater than 1 bar, then alarm will appear like here. The ECS will identify the erratic one and same will be discarded automatically. average of the other two reading will be taken. So we are going to see some example for that. Example 1. So here this reading we are talking about. Number 1 is 2 bar, number 2 is 2.3 bar, and number 3 is 3.1 bar as shown in this picture. We can see over here that difference between number 1 and number 2 reading is 0.3 bar only, and number 2 and number 3 is less than 1 bar, but difference between number 1 and number 3 is more than 1 bar. So what the action ECS will take now? ECS always tries to discard highest reading, so 3.1 bar will be discarded and average will be now 2.1 bar. So average, you can see over here, it is now 2.1 bar. This reading has been discarded and only ECS is reading number 1 value and number 2 value. Alarm will appear for the discarded one. That means which one will be discarded, we will find the alarm for that one. For example, if you find here alarm like SU2 deviation, it means you should understand that number 2 pressure transmitter reading has been discarded by engine control system. Discarded means only reading is omitted, not the channel is invalidated. Invalidation of the channel is something different and omission of any values is something different. We will discuss regarding that in coming chapters. Now we will see the example number 2. Now suppose the reading is number 1 0.9 bar, number 2 2.3 bar, number 3 3.6 bar. In that case, difference between number 1 and number 2 is more than 1 bar. Difference between number 2 and number 3 is also more than 1 bar. So what the action ECS will take? ECS will discard reading of 2.3 and 3.6 bar and finally read 0.9 bar. Why? Because it will sense that according to algorithm all readings are erratic because difference between individual readings is more than 1 bar. So it will assume that all values are erratic and hence higher values will be discarded and the lower value will be accepted. Running the engine at 0.9 bar is not safe. If local pressure gauge is showing correct pressure, that is 2 bar, then invalidate number 1 sensor. Now the reading will be 3 bar. But before that you have to be very sure that pressure is correct, that is minimum 2 bar. Okay. Next thing is that remember, if you invalidate one pressure sensor channel, then ECS will not discard any other reading even the difference between two reading exceeds by 1 bar, which is applicable in this case. In this case, all readings are erratic because difference between any two readings is more than 1 bar. And if you invalidate any channels, then ECS will not omit or discard any other channels input values and it will take the average of remaining two values. I hope this is clear. Now moving to example number 3. Number 1 reading 0.5, number 2 reading 1.7 and number 3 reading 3.0. In this case, difference between number 1 and number 2 is more than 1 bar, between number 2 and number 3 also more than 1 bar, and between number 1 and number 3 also more than 1 bar. So what the action ECS will take? ECS will discard reading of 1.7 bar and 3 bar and finally read 0.5 bar and engine will be shut down. So now what to do? Confirm from local pressure gauge. If reading is 2 bar, then invalidate transmitter number 1 reading. Now ECS will take average reading of remaining 2, that is 2.3 bar. Now engine can run. So this action you have to take in case you find similar type of situation. Now going to see example number 4. Reading is 1 bar, 2.9 bar and 1.5 bar. The difference between number 1 and number 2 is more than 1 bar. Number 2 and number 3 also more than 1 bar, but difference between number 1 and number 3 is not more than 1 bar. So what the ECS will take action? ECS will discard reading of 2.9 bar and finally read average 1.2 bar because as per the algorithm number 2 unit reading is erratic. Now what to do? In this case, no need to do anything. Now going to see example number 5. Number 1 reading 1 bar, 2 reading 2.9 bar, number 3 reading 2.5 bar. Difference between number 1 and number 2 is more than 1 bar. Difference between number 2 and number 3 is less than 1 bar. Difference between number 1 and number 3 is more than 1 bar. So what the action ECS will take? ECS will discard reading of 1 bar and finally read average 2.7 bar. Why? Because as per the ECS, the number 1 unit reading is erratic. Now we have seen total 5 number of example, and I hope you must have a fair understanding about how this algorithm is working. And in case in your life similar kind of situation arises, then you will be able to handle it properly. Now one question is for you. What will be the final reading in this case? Suppose number 1 reading is 0, number 2 reading is 2.5 bar and number 3 reading is also 2.5 bar. Then what reading will be discarded by the ECS and what will be the final reading of LP? The answer is final reading will be 2.5 bar and discarded pressure transmitter will be of number 1 unit, that is 0 bar. Okay, now we are moving next. Here we are going to discuss about some important points. If you find any sensor value erratic, same can be confirmed by local pressure gauge. Please invalidate that one. You cannot invalidate all 3 LP or HP pressure sensor because engine will be shut down. At least one should be in working. That means all these 3 and all these 3 cannot be invalidated. At least one channel from here and one channel from here must be in working condition. Okay. If this channel invalidated, then only control will be changed over to other pump, otherwise not. You can see clearly in this example that even though the reading of number 1 pressure transmitter has become 0, but still control is in with number 1 pump. That means if this type of situation occurs, then please don't forget to switch the control to other pumps, because the control change will be not done automatically by engine control system. You have to do it by yourself. Now one question is, in the case of 5 pumps, how this reading is generated? Is that average of 3 or is that average of all 5? For your knowledge, this is the average of all 5, not average of only 3. Okay, now moving next. Now here I am going to show you that how these 2 types of non-return valves look like. For that I am representing one hydraulic diagram. In this diagram, the graphical representation of this valve has been given. But how do they look exactly? They look like this one. This valve is also called as cartridge valve or logic valve. Now moving next. Now we are going to discuss about the drive mechanism of hydraulic system. By seeing this picture, it is clear that all these fitments are basically situated at the bottom part of the engine. This is flywheel, means HPS system is directly attached with this flywheel. This type of setup we will find when the engine cylinder bore is less than or equal to 50 cm. Just going to give a brief explanation of all these parts once again. This is accumulator. This is safety and accumulator block. All these are 3 engine driven axial piston pumps with flow control by engine control system. Generates hydraulic oil pressure up to 250 bar. Redundancy. The engine can operate on 2 pumps. The third one pump is only just for redundancy purpose. That's we have already talked about. This is called the gearbox. Now we are going to see the internal parts inside this gearbox. So when we open this front cover of the gearbox, we can see. So when you will open this front cover of the gearbox, then you will see all these mechanisms, which include some output wheels like this 3 numbers by which sauce plate pump is connected. These 2 are intermediate gears and this is the flywheel. This gear wheels is situated on the flywheels. Now if we see the close view of this part, then we can see here there are 2 number of gear basically situated on the flywheel and only one gear is provided for the intermediate gearbox. This is the side view of the same. You can see clearly that there are 2 gears situated, whereas here intermediate gear is only one. Now question is, why two gears are fitted on the flywheels, whereas these intermediate gears are not provided in two numbers. Answer is, since changing of the gears on flywheel is very tedious job, whereas the changing of these intermediate gears are easy. That's why there are two numbers of gear has been provided on the flywheel. Here written two rows of gear, one is a spare and separated by a spacer. Gear ratio is 12:1. Now moving next. Here we are going to talk about the hydraulic system pump mechanism in case of cylinder bore is more than 50 cm. Then the whole fitment is situated over here, not at the bottom. So it will look like this one. In this type of mechanism, the chain drive is used, which is attached with the crankshaft. Then it passes through the intermediate gear, which also act as a chain tightener, and then after it goes to the driven gear. After that it is attached with the output gears, which ultimately drives the HPS pumps. Now question is, why this is not situated at bottom as like we discussed before? Why it is situated over here? The answer is, this system is quite bulky and cannot be accommodated at the bottom area of the engine. That's why they are situated at little bit higher place near to the maneuvering platform. Now we are going to see in detail this type of layout. This is basically the side view of whole arrangement. Here the gears situated on the flywheel, then this is the intermediate gear, and finally this is the driven gear. This part is shown as chain drive. Now going to see the close view of this arrangement. So here this is the driven part of the chain drive, this is the step up gear, this is the output gear by which sauce plate pump is connected, the chain wheel which is used of 4 inch and are duplex chain. Now moving next, you will find this sort of arrangement which are shown here in this picture beautifully. This is the HPS auto filter unit. Here these two are electrical driven starter pumps are situated. Now you can see how the construction is actually. This is driven by the chain, this is the step up gear, and these three are HPS pump. These two are electrical driven starter pumps, and all the high pressure line goes to this safety block unit, and then from here it is distributed to all hydraulic cylinder units. Here the easy access for chain tightener has been provided just below this whole assembly. The whole system is shown here as a separate view. This is shown in fully open condition and this is shown in the cover condition except these three pumps. This is the inlet manifold for the hydraulic oil, and all these are outlet going to safety block. Now if you talk about the larger engine, then obviously it will have the more number of cylinders. In those type of engines, the hydraulic systems pump assembly are situated in the middle of the engine, as you can see clearly in this picture. Here these two are starter pumps, and here all 3 or 5 HPS pumps are situated, right? Now moving next, you can see these two are electrical driven pumps, and here engine driven all 5 pumps are situated. Now going to see some more picture related to the same construction. Here this is the separate view of engine driven HPS pumps assembly. Here accumulator blocks are there, safety blocks. At one end binary type of pumps are situated, and at the other ends all 3 proportional type of sauce plate pumps are situated. In this type of construction, the gearbox is unchanged what we saw in the previous construction. These are hoses from pumps to accumulator blocks, pumps turned for easy piping and mounting of low pressure pipes. Improved access of valves. Here you can see you can easily access all valves which are installed in this piping system. Common drain pipe on both sides of HPS, means this side and this side. Drain valves on low pressure pipes. So these are some salient points about the HPS pumps assembly situated over the larger engine. Now moving next, here some other type of construction has been shown in which electrical driven starter pumps are situated at the SU block platform and engine driven pumps are situated below these pumps. In the larger engine, you will find the triplex chain drive has been used instead of duplex. And as far as the construction of gear is concerned, it is almost same what we talked about in the previous design. Now going to talk about a very important part that is called torsional coupling, and in the MMD lot of surveyor ask question related to this torsional coupling. Now going to see where exactly it is fitted. This torsional coupling is fitted over here, which acts like a transmission device between gear and sauce plate pump. Another example, it is fitted over here. Now going to see how exactly it's look like. So this part is called the torsional coupling whole assembly. This is the gear end and this part is the pump end. In this torsional coupling, this pink color part is actually the consumable parts which shear off easily in case of sauce plate pump get seized. So this is the actual picture of this part. This is the driver side, this is the driven side, and when sauce plate pump gets seized, then it shear from this area. So when you go on board, then please have a look that these parts you have on board as a spare or not. Now going to talk about our next topic, that is the control principle related to the HPS system of the ME engine. Now here going to talk about the automatic mode of operation and manual mode of operation. Probably you might have forgotten about the same, so I am just reminding you once again. So I am talking about this HPS mode which is kept in auto or in manual. Now here I am going to discuss about some salient point about the automatic mode and manual mode. So first is the pressure set point is depending on the engine load, means as the load increases, hydraulic pressure also increases, and as the load decreases, hydraulic pressure also decreases. Next is the pumps have two running modes. Number one is pressure control mode, that will be symbolized as CTRL, selected via the MOP screen, and second is follow mode, which will be symbolized as FOLW. The control pump is running 50% and compensates immediately for deviations between actual pressure and set point. Over time, the follow pumps will take over the compensation while the control pump goes back to 50%. In case the pressure controlling pump faces a failure, one of the other pumps will take over pressure control. That's we have already discussed. Now going to explain these two, and also regarding this third point we will see with some examples. So here you can see number 2 pump is in control mode, so it is symbolized as CTRL, and number 3 and number 1 pump in follow mode, so it is symbolized as FOLW. As I told you before that when load changes, pressure also changes. Control means this pump will compensate rapidly any demand of hydraulic oil, whether it is due to load change or due to leakages. During the rapid compensation, sometimes load rises to 100%, but it exists only for just a bit. Now moving next, we are going to see the example part related to control and follow mode. Here I am representing example number 1, and in that example it is assumed that engine is running at lower load. In that case, control pump will run about 50% load and follow pumps will run at the lower load around 30%, 25%, 35% like that. Now in example number 2, the engine is assumed to be at moderate load. In that case, the control pump will run at 50% load and follows pump will run at more than 50% load, say 60% or 70% like that. In next example, example number 3, the engine is assumed to be run at higher load, and in that case the control pump will run at 50% load and follow pump will run around 75%, 80% load. In example number 4, the engine is assumed to be run at very high load, and in that case the control pump will run at 75% load and follow pump will run around 70 or 80% load. Now in the last example, example number 5, the engine is assumed to be run at maximum load, and in that condition all pumps, whether it is in follow mode or in control mode, will run at 100% load. So I hope by seeing all these 5 examples it is clear that how does control and follow pump behave. Now we have already talked about the automatic mode. Now going to talk about the manual mode. In manual mode, the pressure set point is set by the operator. Regarding this, I have already shown you one video. Set pressure should be as per RPM. Now moving next. Here I am going to talk about the configuration of the hydraulic system in case there are 5 numbers of pumps installed as shown in this picture. In case of control failure of pump, the source plate pump will be forced to maximum capacity in ahead direction. We have already discussed several times. Pump number 1 is controlled by SU1, pump number 2 by SU2 and pump number 3 by SU3. We have also discussed this thing before. Pump number 1, 2 and 3 have their own sensor for system pressure connected to their controlling SU, means talking about LP and HP pressure sensors. Pump number 4 and 5 are controlled by binary signals, either maximum capacity ahead or astern. Number 4 is controlled from ECU A and number 5 from ECU B. All pumps have sensor for suction pressure. If the pressure is too low or all sensors are failing, a shutdown will be activated. Regarding this, we have already discussed. Now we are going to talk about the next topic, that is sensors. Regarding this sensor, we have already discussed before. Just I want to show you once again. This one is for alarm purpose and this one is for shutdown purpose. In the left picture, you can see there are 3 pipes. These 3 pipes are going to individual engine driven HPS pumps suctions. And you can also see that some taps are there which are coming from individual pipes, and these pipes are going directly to individual pressure sensors. This pressure sensor is termed as the HPS pump inlet pressure. That is this 1, 2 and 3. Okay, alright. Now going to talk about the sensor part of the engine driven source plate pump. So it has only one sensor, that is the source plate position feedback sensor, that is mostly connected with the channel number 34. Another electronic part is channel number 70 driver, and this is a purely mechanical part which is called the pilot valve. Another sensor part is these 3 high pressure transmitter. These are installed over here. This 3 number you can see. So only that much sensor part is fitted in the HPS system. Now moving next, we are going to talk about the next topic, that is electrical driven pumps. First we are going to see about the mounting and assembly. Regarding mounting, these electrical driven HPS pumps are having vertical orientation, as you can see in this picture. Motor on top and pump are situated at the bottom. These are also designed for easy assembling. Moving next, these pumps are also designed to facilitate easy dismantle and maintenance. For example, if you want to carry out any job on pump part, then just remove some bolt and slide down this pump part and carry out any maintenance easily. In the same way, if you want to do any maintenance on the motor part, then just remove some screw and lift the motor part from its place. Now going to talk about the electrical driven HPS pumps properties. Generally 3 or 4 pumps are installed, and in this case the starter pumps requirement automatically vanishes. As an example, if there are 4 electrical driven pumps installed on the engine, then 2 pumps are running at a standby. When engine load increased, next pumps are started automatically with time delay of approx 2.5 seconds at above 90% of each electrical driven pump, and share the total swaz plate percentage. Now we are going to understand the same with help of examples. Suppose there are 4 pumps. When you put the engine on a standby, then 2 pumps will run about 10% load. And when the engine load increases and it reaches above the 90% load, then the automatically third pump will start and all 3 pumps will now share the equal percentage of swaz plate angle. So in earlier case it was total 180%. So now it will become 60% in the individual pumps. Now suppose again the load percentage is increased and it reaches to say 90%, then the fourth pump will start automatically. In that case, since number 4 pump is of fixed type, so it will run at some specific load and rest other pumps will share the equal percentage of the swaz plate angle. Next, one pump is stopped automatically with time delay of approx 15 seconds at below 50% of each electrical driven pump's load. So now going to understand with example. Now suppose all 4 pumps are running and now load has started decreasing. So once it reaches to below 50%, then one pump will be automatically stopped with time delay of approx 15 seconds. The stopping pump will be that which one is fixed type. This 4th pump has some mechanical stopper, that's why it cannot go beyond 85% of load, and also it is fixed type, as I have stated before, that it cannot run at lower load or higher load, it will run at 85% fixed load. Okay, so when it will go beyond 50% load, the situation will be like this. So 4th pump will stop automatically and total swaz plate angle will be shared with the 3 pumps equally. A start stop percentage can be changed without notice. So engine control system will not notify you that I am going to start the pump, I am going to stop the pump, etc. It will be done automatically without any notice. Now moving next, we are going to talk about our next topic, that is valve block. In this topic we will discuss about some hydraulic circuits also. This particular equipment is called safety block. Its other name is valve block, and the major components which are installed on the safety block or so-called valve block is valve number 310 and valve number 311. In some model, accumulators are also installed on the safety block. This safety block is example of the MEC engine. In MEB engine, the safety block configuration is quite different. We will talk in detail about the same in chapter MEB engine. Okay. Now moving next. Here we are going to see the concept of P1, P2, that denote the pressure, and familiarization of some hydraulic circuits. This is the MOPS screenshot of hydraulic system. First point is that mechanical driven HPS pumps outlet is termed as P1 in the MAN BMW hydraulic circuit diagram. This is the outlet line of mechanical driven pump. So this line will be termed as P1. Next is electrical driven HPS pumps outlet is termed as P2 in hydraulic diagram. And this statement is true for not only starter pumps but also electrical driven HPS pump as well. So this point will be termed as P2. Now we are going to see the same thing with some examples. This is the 3 pump configuration where 3 electrical driven HPS pumps are installed. Here M is written under the circle, that's indicate the electrical motor is fitted to drive the HPS pump. This can also be understood with the help of this P2, since we know that P2 indicates the outlet pressure manifold of the electrical driven HPS pumps. That means if I see only this P2, then I can understand automatically that this hydraulic system is denoting the electrical driven HPS system. That is the significance of this P2 and P1. Although here written electrical driven HPS pump for easy understanding, but if you see P2, then no need to see any other things, you can understand easily. that this diagram is depicting about what type of system. So this is the pure electrical system. Now here I want to emphasize on one point, that all proportional type of sauce plate pump need a feedback from the outlet line in order to function properly. For example, in this system, this arrow is denoting that this sauce plate pump is of proportional type. That means it required feedback to function properly. So you can see here from point B1, one line is coming and this line is going into the point SP. SP is denoting the sensing point. That means it's act as a feedback. This channel number 70 job is only to set the desired pressure, and by help of this SP and B1 point, this sauce plate pump maintains the desired pressure. I hope this is clear. One small thing I also missed out about this waste tank. Waste tank is nothing but a small tank in which you can drain some contaminated or unused oil, or if you think that the LPS line has some impurities, then you just open this drain plug and then oil will drain out in the waste tank. This waste tank is not installed on each and every ship. You will find rarely a ship having the waste tank installation. Now moving next. In this diagram, the two pump configuration has been shown. Here also written P2, that means this is electrical driven HPS pump system. So this is also a pure electrical configuration. Now going to see some another example. Here I will not see this combined HPS, common LPS, etc. I will see just only P2 and P1. That means I can understand that this system has both type of HPS, engine driven as well as electrical driven starter pumps. So this is the mixture of mechanical and electrical. Now once again I want you to focus on this point SP. In this configuration you can see that this SP is not connected with the B1 as we saw earlier, but this SP line is connected with this P2, that means electrical driven HPS pumps outlet manifold. Okay, when there is a combined HPS system is installed on the ship, then in that case this SP point is connected with the P2, not with the B1. Why? Because startup pumps start first, and on the basis of that pressure, rest of the engine driven sauce plate pump function. I hope this is clear. Now we are going to see the example of SP point. This is the safety block. This is 2 bar LPS line. These two are outlet of the both starter pumps, and these three pipes are sensing line for individual sauce plate pump, what we just saw in this previous hydraulic diagram. Here you can find SP is written. SP means sensing point. This is HP outlet from individual sauce plate pump. Here we are going to see the position of valve number 311 and 310. This is 311 shown in the hydraulic diagram. Here this valve is 311. Here also stamped on the body 311, as you can see. This valve number 311 is named as system backup relief valve. Set pressure is 250 in 200 bar system and 315 in 300 bar system. Next is valve number 310. This is the valve number 310. It is also stamped on this body over here. Its name is system relief valve. Set pressure in case of 200 bar 230 bar, and in case of 300 bar it is set at 310 bar. Now going to see the release pressure of valves of 200 and 300 bar system. Valve number 310, 311 and 312 as we saw in the hydraulic diagram. In 200 bar system, this valve number 310 is set at 230, 311 250, 312 175 bar, and in 300 bar system 310 is set at 310, 311 is set at 315 and 312 is set at 225. Now going to talk about the function of different valves. So first is function of valve number 316. Just for remind, this is valve number 316. This is normally closed valve, but when opened along with valve number 310, then it's drain all hydraulic line including SU. When you have to work on SU, then open valve number 316. So as you know that these are SU, hydraulic cylinder unit, and if you need to work on SU, then it need to be drained completely. In that case, once you open this 316 along with 310, then all oil will drain out, and thereby the hydraulic cylinder unit will be completely dry. Next function is in order to test leaky non-return valve of engine driven pumps. These are non-return valve fitted on individual engine driven HPS pump. Suppose this is leaking, then how we will come to know? In that case, what we have to do? We have to start these startup pumps and open this valve number 316. After that, we have to shut the inlet valve of the concerned pump, and after that just open this pipe. If oil is coming, then we will come to know that this valve is leaking. By this way, we can check the integrity of non-return valve with help of this valve number 316. Now moving next, how to set valve number 310 after repair work. Before overhauling, it is must that you mark the position of a spring tensioner. Now you will be curious what is a spring tensioner. Just for your reference, I am representing one hydraulic valve picture to make you understand about the spring tensioner. This part is called the spring tensioner. So before overhauling, you have to mark the position of this spring tensioner in terms of number of threads or height. Okay, next, position the spring tensioner little loose with respect to mark point. Run the engine and change the HPS mode to manual. Set the pressure to 315 bar. That means HPS mode you have to make it manual from auto, and change the set pressure over here to 315 bar. Next step is observe the pressure from MOP and adjust the spring tensioner. Means after correct adjustment, the pressure will not rise more than 310 bar. Excess pressure will be released through valve number 310. I hope this is clear. Now moving next, how to set valve number 311 after repair work. Before setting the valve number 311, you have to set the valve number 310 to 320 bar approx. Then set the valve number 311 like setting of 310 as stated before, and then set the valve number 310 again. Why it is done? Because valve number 310 is set at 310 bar and 311 is set at 315 bar. So in order to test valve number 311, you have to raise the set value of 310 more than 315 bar, that means approx 320 bar, then only we can set the valve number 311. Alright, now moving next, how to set valve number 312 after repair work. This is valve number 312. Shut all SU valve number 420 and 560. See diagram. You have to shut this valve number 560, which is going for lubricator, and also valve number 420, which is going for the FIBA. Start the startup pump in order to generate hydraulic pressure, of which valve number 312 has to be set. Gradually set the release pressure. Why these two valves need to be shut? Because unless you don't shut this valve, hydraulic pressure is not going to raise, since there is some internal leakages are always there in the hydraulic cylinder unit. Now moving next. Now we are going to see the function and internal construction of valve number 310 and 311. This is a illustration of a common valve which is used in valve number 310 as well as in 311. First of all, going to discuss about valve number 311. This is the internal construction of main valve of 311. Inlet hydraulic pressure is needed in order to keep this valve in shut position. This is the hydraulic diagram of valve number 311. Here the main hydraulic pressure acts on the port number A and it comes out from port number B. This is port number A, which is the inlet, and this is port number B, which is outlet. One line of the main hydraulic pressure passes through two orifices and acts on the back of the poppet valve in order to keep this valve seat tightly against any pressure. This is a pilot valve which is responsible to operate this main valve. This blue line is connected to the port B and this port B is connected to the drain. When hydraulic pressure increases to 315 bar, then this pilot valve ports open and here this pressurized line becomes depressurized and thereby this holding pressure which was acting at the back of this poppet valve also disappears and hence the main valve opens. That makes port A and port B short circuited and finally whole pressurized oil leads to drain. So that is how this valve number 311 function. That means this valve 311 actually is a combination of two valves. This is the main valve and this is the pilot valve. Now I am going to show you the valve number 311 function with help of animation. Now you can see that once it reaches to 315 bar, then this pilot valve opens, this line depressurized, this valve open and whole oil this goes to the drain and thereby hydraulic pressure disappears. Now moving next. Now going to discuss about the valve number 310. This hydraulic diagram is representing valve number 311 and valve number 310 circuit. This is representing valve number 311 and this is representing valve number 310. Up to here both valves look similar. There is no difference. The only difference between 311 and 310 is this two solenoid. As I explained before that if I depressurize this part, then this main valve opens automatically and hence all pressurized oil will drain out through port number B. And this depressurization of the oil is done by the three methods. The first method is by hydraulic oil itself, which activates this pilot valve and hence this main valves open. Another method is by these two solenoid valves. These two solenoid valves work in parallel. This solenoid valve also depressurize this part. How? You can see line is coming over here. When it's activate, then this line goes directly here and drain out. By doing so, this area's pressure goes down and hence the main valve opens. This solenoid valve is activated by SU1 and this solenoid valve activated by SU3 and this whole valve hydraulic symbol is this one. For your easy understanding, I am just zooming the hydraulic symbol of the valve number 310. This black triangle is representing hydraulic pressure of 315 bar. This tilted line is showing this solenoid valve and this tilted line is showing this solenoid valve. Now we are end up with this chapter here only. I hope you must have enjoyed the whole session. I know this session is little bit lengthy, but anyway it doesn't matter at all when it comes to gaining of knowledge. Thank you for watching this video. Bye bye, take care, have a nice day.